Alright guys, welcome back. Like I said earlier yesterday that my son is sick, so we're doing another video. Here are the warm-up problems, so please go through them right now and do them and pause the video because I'm going to go through and tell you the answers. So when we're factoring the first one, it's a difference, or we're factoring by grouping, sorry. So our answer is 5b squared minus 2 and 3b minus 8. On the second one, you've got to pull out a 3, right? And then it's a difference of cubes. And on the last one, it's a difference of squares, 5x plus 3, 5x minus 3. Okay, today what we're doing, go on to the next one, sorry. Today what we're doing is the quadratic equations. So the basics of a quadratic equation is an equation that is equivalent to another equation, or ax squared plus bx plus c, where a is a non-zero. Remember, a can't be 0 or else it is linear. We can solve a quadratic equation by factoring using the principle of 0. So factoring for most people is a lot easier than using the quadratic formula. So this is one way to get the same answer as the quadratic formula. So you can always check these ones by doing the quadratic formula as well. But this is the principle or 0 of products. Oops. So we know when we have a times b equaling 0, then either a or b or both are going to be 0. So that is the point that we're going to start with right there, is that one of those has to equal 0. So we've got this one. So this problem, so that I can show you the 0 product property, is already factored, right? So it's already factored, so this or this is going to equal 0 for the problem itself to equal 0. So to find out which one it is, I'm going to do both cases. I'm going to do t could be 0 in this one, or this could be 0. Let's find out. So notice the equation is given in the form a times b equals 0, so we're going to set each factor, right? A and b both equal to 0 and solve. So we got 4t plus 1 equals 0. So to get t by itself, you subtract 1, then you divide by 4, right? So if t was negative 1/4, then 0 would be our answer. On the second one, we're going to add 5 and divide by 3. So if t was equal to 5/3, then it would also get us 0. So our two answers are negative 1/4 and 5/3, right? If you were to do the quadratic formula on the original, which is not this, but the factored form, if you multiply these two, you would get the exact same answer. This is a lot easier since it's already in factored form, right? So let's move on. So this one, a is 1, so you can do the x box factoring, and you're thinking to yourself, what multiplies to 6 and adds to 7? Well, what multiplies to 6 and adds to 7 is 6 and 1. Right? So we got 6 and 1. Now once we know both factors, right, we can plug those in, or set them equal to 0. So we got x plus 6 equals 0, so x equals negative 6, or x equals negative 1. Again, this is a lot faster than doing the quadratic equation on the top one, where a is 1, b is 7, and c is 6. So we got our two answers are negative 6 and negative 1. Ready to move on to the next one? Here's the other one. This quadratic is a quadratic equation, but it's not in the correct form. The correct form is ax squared plus bx plus c. And currently our c is on the wrong side of the equal sign. So we're going to have to move the 25 over. Now that it's there, right, we're going to go back through and we're going to factor it. So again, a equals 1, so this one should factor easily. And you get x plus 5, x plus 5. This is a perfect square trinomial. So we're going to set each of those up equal to 0. And you notice that you get the same answer. So x plus 5 equals 0, we get x equals negative 5. And here, we get x equals negative 5. What this would be in the quadratic formula is the fact that the discriminant is equal to 0. And so you only get one answer, and your one answer is negative 5. It's a repeated root. It also means that the vertex of this problem is on the x-axis. So that vertex again is the peak or the maximum. So let's have you guys do this one on your own. Take a second, pause the video, and try this one on your own. So welcome back. This is not in the correct form, so I've got to move it to the correct form, so I'm going to subtract 2. Right? This one's a little harder because it doesn't factor quite as easily. You've actually got to do the x box. So if you factor the left side, right, you get 3y minus 2 and 4y plus 1. This should be your factors from the x box. Right? From there, it's the exact same thing. 3y minus 2 and 4y plus 1. We set each factor equal to 0 and solve. You get y equals 2/3 and y equals negative 1/4. From there, it's the same. So if you could factor well, this is not a huge extra step that we're taking and able to find the actual roots of the problem. These are the points on the graph where the x or the parabola actually crosses the x-axis. That's what we found. So this parabola, if we're drawing it, is crossing at positive 2/3 and negative 1/4 on that x-axis. Those are two different answers. Again, here's another one. This is not in the correct form. So we're going to put it in the correct form. You may notice that there's a greatest common factor here. So this is going to lead us down a different path. Right? So we're going to factor out that left side. We get x times 5x minus 6. You'll notice that this could be our a and this could be our b, right? If we multiply these two things together, we're going to get one of them has to be 0. So I set them up like so. Where first one, if we set up as x equals 0, well, that's already solved. There's nothing more to do there. And then we've got the next one, where 5x minus 6 equals 0. We're going to add 6 to both sides and then divide by 5, and x equals 6/5. Right? So this one's a little easier because you could take out that greatest common factor and then you're like, boom, it's already factored. That's so much easier. So, going back and forth. Alternative method of solving a quadratic equation is using the principle of taking the square root of each side of an equation. So, if x squared equals a, then x equals plus or minus the square root of a. You'll remember doing this when we were solving at the beginning, in 6-1, we did stuff like this. So what I mean in the context of this problem is we've got 3x squared minus 36, right? So another way to solve this one is, what if I move 36 to the other side? I can do that, right? And then I can divide by 3 and I get x squared equals 12. But in all the other problems I'm solving for x, not x squared. So what do I do here? I take the square root of 12, right? But that's actually got two different answers. It's got the positive and the negative square root, and then we're going to reduce it, and you get x is plus or minus 2 rad 3. Because again, if you plug this into your calculator, it's going to get a decimal. If you square it and it's negative, you'll still get 12. If you square it and it's positive, you'll still get 12. So both answers work. Again, you're going to have both answers here, or two answers, because the discriminant of this problem is a positive number, right? And when the discriminant is positive, you've got two real solutions. If the discriminant is negative, you have two imaginary solutions. In this case, it's positive. So try this one. Take a second, pause the video, and let's work through this one. The first thing you're going to do is divide by 4. And when you do, you get z minus 3 squared equals 25. Okay? Well, I got to get rid of this squared. So what's the opposite of taking the square? Taking the square root. So what if I take the square root of both sides? It's z minus 3 equals plus or minus rad 25. Well, we know what the square root of 25 is, right? It's 5. So now I've still got to solve for z, so I want to move this 3 over. So I get 3 plus or minus 5. So we can actually do those problems. This is 3 plus 5, we get 8, and 3 minus 5 gives us negative 2. So our answers are 8 and negative 2. Right, so this is solved, again, by taking the square root of both sides. Sometimes this would be faster. Could you factor this another way? Yes, you can change this into standard form. Right, you can change this part up here into standard form and factor, and you would get the exact same two answers. Or change it to standard form and use the quadratic formula. You would get the exact two same answers. Oops. So, solve by taking the square root again. So, first thing you're going to do is isolate that part that we can take the square root. So we're going to add 75 to both sides and then divide by 5. Gives us 15. Now that we've got the square root by itself, we can actually take that square root of both sides. So you get x plus 5 equals plus or minus the square root of 15. If I want to solve for x, I'm going to move 5 to the right. You get x equals negative 5 plus rad 15, and x equals negative 5 minus rad 15. Okay, perfect square trinomials. This will go faster. Again, perfect square trinomials look like this, right? We talked about the problem with some of these is they're hard to recognize. Again, you can always use the X box on either method here, and you'll then see that this is the answer. But the faster way to do it would be to recognize it as a perfect square, and then solve from there, right? So, let's go through. Remember, you can factor, if you can't factor, always use the quadratic formula. So I know that's kind of hard to see with the yellow, or the green. Remember, if you can't factor, use the quadratic formula and you'll get the same two answers, right? The only problems that don't work are equations where the parabola does not cross the x-axis, are imaginary numbers where a discriminant is negative. Okay? So here's practice using the quadratic formula. So we've got our a, b, and our c, and we plug into the quadratic formula. Right, so our a is 1, our b is 7, and our c is 6. Again, showed up there, our a is 1, our b is... Sorry, we had a little technical difficulty. Your a is your x squared term, your b is your linear term with x, and your c is by itself there in the last term. So we recognized a, b, and c. From there, you're going to plug it into the quadratic formula, so it looks like this, and then reduce, right? So 7 squared is 49, and 4 times 6 is negative 24. You subtract, you get negative 7 plus or minus rad 25 over 2, right? So it's negative 7 plus 5 divided by 2. You'll notice that there's parentheses, because if you do not put those parentheses for your calculator, it will not show you the answer. So you get negative 1 and negative 6 as your two answers. We also did this one at the beginning of the day, and you'll recognize that the answers are exactly the same. So again, using the quadratic formula to solve, we've got a is 2, b is 1, and c is negative 10. Right? 2, 1, and negative 10, and then we plug those into the quadratic formula. And then we solve, right? And we get negative 1 plus or minus 9 over 4. And our two parts, our two answers are 2 and negative 5 halves. Okay. If there's any questions, please write them down so I can go over them on Thursday, because we've got tomorrow off. And I know I have quite a bit of homework to check. Again, come with any questions, and we will check those on Thursday. If you have any other questions, please email me at cstrong@losal.org, and I'd be happy to help. Remember, you can always check your own work. If you factor a problem, then set the factors equal to 0, you'll get your x-intercepts. You can also get your x-intercepts by solving the quadratic equation, and so those two answers should match. So if they do match, you are correct. Oops. And there is your homework, page 229, 9 through 17, 40, and 57. Have a great day, guys.